this video clip I will show you how to work with the external standard method in peak symbol. First you open a suitable control file. And that would be the default one for HPLC, because HPLC is normally where we work with the external standard method. Okay, and then you just save it as something you can recognize, and I've made a folder for this little experiment. I'll just call it test external standard HPLC and save. And then there's this little trick with peak symbol. You need to open it, the one you just saved. So, and now you can see we have our new control file open. Okay, the next thing we need to do is to create a components file, so peak symbol can recognize the peaks that we actually see. And we do that by opening one of the standard chromatograms. I'll pick the one with the highest concentration, so then I'm sure I can see the peaks and I can see them in their largest form. Okay, so this is the peaks, and from the information you got for this exercise, you know that the first one is hexane and the second one is octane. So we need to create a component file that can show us that. We just right click, press add component, and then right click again, edit component, and this is peak number 1. It was hexane, and we know the units as well. They are ppm. We enter those as well. Okay, we do that with the second one. Add component, right click again, and edit component. That would be peak number 2, and that's octane. And the unit is ppm as well. Okay, then you can see there is a bit of an overlap in the retention time windows, so we just make them a little smaller so they do not overlap. And you just, when you can see the little arrow, you can just push the left mouse button and make it smaller or bigger. So quite simple. Okay. It is very nice to save the component file, and you can do that by entering edit, channels, and then pick components. And then you can see you have your component table, and we just save it by clicking save. And it seems like I've done this before, so I'll just pick this one, save, and yes to overwrite. Okay, so now I've saved my components file. Okay, so the next step is the actual calibration by using the external standard method. So now we need to open the standard with the lowest concentration, because peak symbol cannot work from high concentration to low concentration. Then it will think that there's something wrong. So we start off by using the standard with the lowest concentration. That will be 100 ppm. Open. Okay. So what we need to do now is right click, and then we click Calibrate Hexane. And we do not want to use a template or anything. We just go for a new one, and level number 1, that will always be 0.0, so we go for level number 2, and you can see level 1 0.0, and here at in this cell we enter the concentration, and that will be 100 ppm, and then we say accept new, and then you can see the area of the hexane peak is in this cell. We also need to choose the regression method, and we normally go for single line AX plus B. That would be equivalent to linear regression as you know it from your calculator. Okay, and you can see in this area you have three options. This current one, that is when you only have a single determination, but if you have more than one determination of your standard, then you can pick one previous area also, or two previous areas also. One previous, that will give you the possibility to enter two values at each level, and two previous, that will give you the possibility to enter three values at each level. But in this case we only have one value at each level. So before we can leave this, we need to save it. And I've again done this before, so I'll just pick the same one, but you can enter any name you like. Save, overwrite, yes, and then we can close this one. Then we need to do the same for Octane, so calibrate Octane, and you can just go for no. Level number 2, okay, concentration is the same, 100 ppm, accept new, and you can see the area for the octane peak is entered in this cell. Check the method, single line, okay, and save, and we just save it in the same. Yep, to overwrite and close. So now we open the next standard in the row, and that will be the one at 200 ppm. Oh, right click, calibrate, and this will be level number 3, and the concentration is 200. Accept new, close, and it automatically saves now. Choose octane, calibrate, that would be level number 3, okay, 200 ppm, accept new, close. The last standard, open, that would be 300. Same procedure, right click, calibrate, level number 4, okay, that was 300 ppm, accept new, close. You do that the same for octane, calibrate, level number 4, okay, 300, accept new, and you can see, we can actually see the line here. So, and that's at this stage, just as a precaution, I normally press save. I'll just save it in the same. Yes, to overwrite. Okay, so now we have entered all the values and we've calibrated our method, and you can have a look at the statistics by clicking statistics. Then you can see the average slope, the y-intercept, linearity is good, and you also have the r-squared value here. Remember that we normally talk about just the r value, so you need to take the square root of this value if you want to calculate the correlation coefficient, and you have the formula down here as well. So that's okay. Close. So we're done. The next thing we can do is we can actually determine the concentration of these two components in our unknown sample. So we just open the sample file, and we can see we have hexane and we have octane, and if we view results, then you can see the component hexane have a concentration of roughly 238 ppm, and octane is in the concentration level of 162 ppm. And I think that is more or less what the teachers set of data show. So this is how you do when you work with the external standard method.